Hmm. Okay, so this is just like a little update, a little refresher course as to uh, speed of light, and because I'm not sure if everybody's understanding what's going on with the speed of light, because I've said it before many times that Einstein drilled into people's minds that the speed of light is constant for everyone in a frame of reference. What that means is that it's not going to change. It's always going to be 186,000 miles a second or 300 meters per second, whatever it is. But yeah, I have to say, I'm a little bit old school. I learned 186,000 miles a second. Anyways, it's true. It's true. It's never going to change. It's never going to change from being the speed of light is always going to be 186,000 miles a second for everyone, everywhere they are, no matter where they are. Everyone is going to see, or if they can detect the speed of light, it's going to be that speed. Or, in other words, it's um, as far as we are concerned, as as genetic organisms with mass, we are always going to observe that speed of light because we're not quantum, we don't exist at the speed of light. We don't exist at the speed of light, so we don't have the effects of special relativity that does away with time and distance. There is no time and distance in quantum physics or at the speed of light. That's why there's a particle here and a particle there. They interact with each other and they're instantly associated with each other and stuff because there is no time and distance in quantum mechanics or at the speed of light. But we don't exist at the speed of light. We exist in a fabrication of in a universe that has gravity, that has uh, dilated time and distance, that slows down time and distance where we are at a specific rate. But to say that the speed of light is constant for all observers is a little bit misleading because if you look out into outer space and see a galaxy, uh, you're going to be seeing more than just your frame of reference of the measure of time and distance where you are, where you happen to be. You're going to be seeing, you're looking across great distances, even though it's a little speck in the sky. That galaxy covers a great distance, and in that great distance is going to be a huge fluctuation of variation or variable time and distance, or time and distance. Gravity is going to affect the frame of reference all across that galaxy and outside of the galaxy. Outside of the galaxy is going to be even more affected or less affected by gravity, more or closer to the quantum world where there is no time and no distance. In other words, time is goes by instantly fast. Distance is uh, well extremely expanded, but But if you're at the existing at the speed of light, no matter what the distance, you're always still there. I mean, in other words, because there's no time. It takes no time to travel no distance in in special relativity and in the quantum world of physics. So no matter what the distance is, you're still always there because there's no time and no distance at the speed of light. But it's the opposite effect for when you go away from gravity. Gravity is going to slow down time and contract distance so that there's no time and distance, but it's different. Oi, Daniel, como é que tá? Deus abençoe você. Igualmente. But when you look across the galaxy, you're not. It's not like looking at a cat or a dog. As this is my illustration. Because if you had a cat or a dog that was the size of a galaxy, that cat would be very skinny in the middle, and its center would be very skinny. Then its arms and legs and tail and everything would be on the outer edges would be greatly expanded, be and moving a lot faster than its center, and that's why the spiral arms of the galaxy are moving faster around than they expect it to be moving compared to its center. I I still think. Let me see. My computer is a little bit slow. Still think we see light from distant galaxies and stars instantaneously, meaning it doesn't take thousands of years to get here. Yeah. And the way this is possible is that the rate of time is faster between us and distant galaxies. So between us and distant galaxies, time is going by real fast, and besides that, distance is expanded, making it actually less distant. In other words, if you look toward the black hole, you're not going to be able to see into the black hole because of how far away it is. And yet, we can detect distant galaxies that are extremely redshifted with a James Webb telescope. So, in essence, those distant galaxies are closer to us than the center of our black hole. So, the time goes by real fast, so we can see the light because time in between the galaxy and us is going by real fast, and light only slows down when it enters our galaxy. See, if the universe was expanding faster than light, and light had to travel to us at great distances, it would look blurred in the direction of travel. Yeah, that would be a problem. And they claim that's what's going to happen eventually, but we don't see it happening yet. At least not like that. But that's what they say is causing the redshift. But the redshift is because in order to reach us, the light is passing by all of these galaxies all over the place, which are all tugging on it and causing the redshift. Because if the light leaves a source that's a massive galaxy, much more massive than our galaxy, that's what causes the redshift. In other words, the light leaving a massive galaxy causes the redshift. Then when the light enters our galaxy or another galaxy, it's blue shifted back to its original spectrum. But what's happening is that it's not always blue shifted all the way back to its original spectrum. It remains redshifted, either because of the mass of the galaxy of its origin, or that is traveling from such a distance that it's when in order to reach us, it's it's passing by all these galaxies. They're all tugging on it with their gravity, and that's what's causing the slight redshift. And the farther away it is, the more galaxies that it has to pass through in order to reach us, causing it even more to be more redshifted. So I don't think these people are really, these scientists, I don't think they're really being thorough or thinking through this stuff, because light is redshifted when it leaves the galaxy, it's blue shifted when it enters our galaxy. And we're not a very massive galaxy, and we're not in the center of our galaxy either. So that's why there's galaxies appear to us to be redshifted. They made claims like the stars we see might not even exist anymore. That can't be true. Light's an electrical circuit without a source. It ceases. Electric doesn't keep traveling without a source. Yeah, well, that's a claim. Their claim is like when they turn on the flashlight, the beam goes out, and then when you turn off the flashlight, the beam stops going, but it's still moving out. But the age of the universe is not as great as what they think. Or, I mean, you can call it age, but it's an age that passes by real fast. Because in between galaxies, it could be like billions of years for the light to reach us, but that billion of years is passing by really fast at a faster rate of time. Plus, it's not traveling as far as what they think it's traveling because distance is expanded, which means it's actually less distant than what it appears to us to be. And that's what the observations show with a superluminal motion. They see these plasma jets shooting out, and they measure the speed of the plasma jet being 7 times the speed of light, which, the only thing that can be wrong with that is their measurement of time and distance as it moves away from the galaxy. The rate of time speeds up. That's what I'm saying. It's misleading to say that the speed of light is constant for all observers, because it's not constant. It's constant in your frame of reference. If you went to another frame of reference, it would still be the same 186,000 miles. But the only thing is that your 186,000 miles isn't the same measurement as what it is over here or over there. So they have the distances and ages and speed all wrong. So lasers aren't like guns like Star Wars. When you turn them off, they stop the beam of light. Just doesn't keep on traveling across space. See, think of it like this: light will travel in all directions from the point of source. So why don't we see blurs of light instead? We see points of light called stars. I think it's amazing. It's amazing that we can even see these stars and galaxies. I think it's just, I mean, it's it's clear. It should be obvious that God put them there for us to learn, for us to teach us, not only of His greatness, His power, and His eternal existence and everything, but it's just so amazing that we can even know what's happening out there. We can, with a spectrum, we can analyze it. We can know the elements. We can know all the interactions. Plus, when you understand gravity and general relativity, you can understand gravitational waves. And to me, it's just so much stuff that is very, interesting, at least to me. But yeah, it's like it's very focused the planets and the galaxies, they're very focused, with the exception of gravitational lensing, which smears things around. But other than that, it is very focused. But the gravitational lensing is proving my point that the speed of light is not constant, because the light from an event that's gravitationally lensed appears in like 3 or 4 different places, but they don't all appear at the same time, proving that light is not traveling at the same speed to reach us. And I mean, you could say, yeah, it was curved, it went a long way around and this way around. That's why it took so long. But when you understand that the light is going through a galaxy or a gravitational field where there's mass that is contracting the distance and slowing down the time, of course, the light's not going to go through an area like that as fast as it would away from the mass. When it goes through a place away from the mass, the light travels much faster, which is the point I'm making. When the light between us and a distant galaxy is traveling to us, is traveling with no restriction whatsoever. Hello, rebuke and reprove. How you doing? So the light's traveling with no restriction to slow it down, and it's it has nothing to make it far away. I mean, there's nothing to contract distance to make it a whole bunch of measurements between here and there, a whole bunch of frames of reference of 186,000 miles from here to there. So the distance is expanded, so there's a lot less frames of reference of 186,000 miles between here and there, meaning it's not as far, meaning it's less distance that the light has to travel to reach us. And I don't think, because I don't hear, the reason why I don't think people are considering it, because I don't hear them talking about it. If they were talking about it, then you could say, yeah, okay, they know about it and they're thinking about it, and they took it into the consideration with their calculations. But since they're not talking about it, they haven't considered it, as far as I'm concerned, as far as I can tell. So that's about it. Some astronauts said they couldn't see any stars while they were in space. That kind of makes sense to me. They, well, if they had the sunlight, if they had the light of the sun, it'd be like daylight, so they wouldn't be able to see the stars. They would have to be in the shade from the sun to be able to see the stars. But if it was like daylight where they were at, or in the sunlight, then they wouldn't be able to see the star, because the light from the sun is too overwhelming. They wouldn't be able to see the stars. They would have to be like in the shaded part, or the nighttime part of the moon. This reminds me of sometimes when we go up in an airplane, sometimes people ask if it's raining outside. I said, no, it's not raining. We're above the clouds. The rain is below the clouds. We're above the clouds. Anyway, see, yeah, I would figure light or electromagnetic radiation is like a rate of induction. Uh, well, they describe it as photons and waves, and you can have waves like in water. You can have waves that start and then deplete, and then of course, when in the initial strike of the waves, and then it'll get less and less. See, with no resistance, it can conceivably travel instantaneous. That's what I'm saying. If there's especially if you have all of the galaxies from all around polling on the photon, whatever it is, that means there's no what do you call it? There's no gravity. It's not experiencing any gravity because they're like in a Lagrange area between 2 points. They're not being pulled this way or that way because everything's pulling it from all directions. So it's not experiencing any gravity or any slowing down of time or any contraction of distance. So the distance is short and the time goes by fast, and that's why it arrives instantaneously. And in my last video, I played a clip of a creationist talking about that. They call it the variable speed of light, VSOL, variable speed of light, which is an actual thing, which I was talking about it, but it's an actual thing that I was talking about. It's electricity. Electricity requires a source and a ground, and there's no resistance. It's going to be fast. Right. Well, the only thing that slows it down, like what I'm saying, light will only slow down and it'll only blue shift as well when it enters a galaxy. And by that time, it's a lot closer, right? And it's still going 186,000 miles a second anyway. So it's not going to take that long to reach us. But it's still outside of the solar system as well. And people don't you don't know how fast what the measures of time and distance are outside of the solar system. These Voyager 1 and 2 things, they're completely disoriented because they don't know where they are because their measurements of time and distance are all off, and so they're trying to reprogram it so that it can figure out where it's at in order to tell us where it's at. It's they're totally lost out there because they don't have any reference of where they're at because the measures of time and distance are all different. See, I don't think it travels at all. It's a wave. Wave is a medium in which travels, waving, like holding a rope between two people, shaking it up and down. Yeah, in a sense, it is connected. It's especially light. Especially light is connected. I mean, if the quantum stuff and the special relativity stuff experiences no time or distance. It takes no time to travel no distance. It's connected. It's already connected. But our perception of it is what takes time. It's not that the speed of light is taking time. It doesn't take time. It's instantaneous. It's our perception because we exist in a fabrication of slowed down time and contracted distance where physical things can take place, physical things with mass that can't travel the speed of light are like in slow motion. So it's our observation of the light that is slowed down because of our contracted frame of reference, our slowed down time and our contracted measures of distance. That's what makes light appear to slow down for us because we exist in like a slow motion. We're like in slow motion. We're not we're not quantum. We're not instantly there. We're not, you know, connected, you know, at all times instantly because we're in the fabrication, the physical fabrication where biological life forms can exist. but your point is well taken. It is true. It's like a rope that's connected. It's already there, and that's true. But it's our observation that takes time, that causes it to take time. But in between galaxies, there's our observation is going to appear fast because there's nothing to slow it down. There's no contraction of or slowing down of time, no contraction of distance. But once it enters into the galaxy, that's when you start having the effects of general relativity because of the gravity of the galaxy. And it's like the plasma jet shooting out. It's not even a light beam. The plasma shooting out from the center of a galaxy is not a light beam. It's plasma. It's physical uh, matter. Even though it's a plasma, it's still matter shooting out from a galaxy. They say it's moving 7 times the speed of light. Of course, it's not moving 7 times the speed of light. That's absurd. It's your measures of time and distance that's not keeping up with how fast it's going. Because the distances expand, it's not traveling as far, and the rate of time is going faster. That's why you think it's traveling 7 times the speed of light when it's not. It's not even traveling the speed of light. But and I'm from the Amazon. I'm from the Amazon. It's not a problem for me to understand. They need an atmosphere. Well, it's the atmosphere that slows stuff down physically. I mean, and it's the general relativity is the contraction of space time that slows things down. Waves aren't traveling; it's the water going up and down. Yeah, but it's the water going up and down, but it will push things. I mean, it can push things, but that would be the gravity. uh, be the gravity pushing the things. But anyway, see. Electromagnetic radiation is exciting the atoms, causing them to illuminate. That is light. Uh, well, they have. I mean, they have detected the particles, the photons. They're basically, I guess, like electrons, but they're photons that are. They have been able to detect them or capture them in some way, which is kind of strange because they don't know in an atom. They don't know where the electron is. The electron is everywhere all the time, which is basically what it's like not to have mass. You're everywhere all the time. There is no distance. It takes no in special relativity. It takes no time to travel no distance. It's like the opposite effect of a black hole, or it's the same effect as a black hole, only it's because of speed instead of gravity. With gravity, you have a slowing down of time and a contracting of distance. And with special relativity, is like the same thing as the gravity from a black hole, only they call it acceleration. They call it acceleration. And they say everything is accelerating, but not if you're in between galaxies. How can you be accelerating or experiencing acceleration when everything's pulling you at you from all angles, all directions? If everything's pulling at you with the same force, you're not going to have acceleration. You're not going to experience acceleration. That means there is no slowing down of time and there's no contraction of distance. Means distance is from here to there. 186,000 miles is from here to the next galaxy, as far as we know. You know, and it to travel, take a second to travel from one galaxy to us at a faster rate of time. You know, that means the speed of light is faster. I mean, it's an exaggeration, but the opposite is true with special relativity. For the electron that experiences time or doesn't experience time because it's the same effect as a black hole, only it's because of special relativity, because of acceleration. But if there's no acceleration, there's no contraction of time or distance. Yeah, it takes a while to figure it out or understand it, but it's interesting anyway. Think about a sound wave. It's not traveling. You're causing the air to vibrate or a wave, which makes a noise. Well, this is the whole thing with the ether. What they eventually supposedly figured out was that there is in space, in a vacuum, there is no medium. There's no medium. There's nothing to travel through, and it's part of relativity. See, my question would be: I understand the sound waves, so how does electromagnetic radiation waves in space? To me, the ether makes no sense. Makes sense. Oh, the ether makes sense. Yeah, well, that's been like the big discussion forever is whether or not there's an ether or a medium or not. In general relativity or special relativity, in relativity, there's no ether, there's no medium, and there's just time or distance, which is kind of a medium. And I don't think there's a difference between sound waves and light waves besides the frequency and power. Well, see, that's the thing. The problem is if there was a medium, then it would slow down light reaching us from distant galaxies. But I don't think it's being slowed down. I think it's almost instantaneous. See, have you ever seen sound create light? Well, there's a lot of things that create light. I mean, it's possible for sound to create light, considering it's, you can make light with, well, friction. With if you're like, if it's completely dark and you move your hand across a rug or whatever it is, you're going to see light, and sound could easily probably make light as well. I mean, but that's because we have an atmosphere. There is a medium. We have a medium, and in space, sound can't travel in space because there's no atmosphere or medium for it to travel. Hello, Scotty. Scrawny or something like that. Sorry if I don't understand. You said hi before us. I said hi. Okay, I think general relativity just replaced the ether with space time. It, uh, well, there's a lot of tests and observations they do to confirm all of this, and a lot of it has been confirmed, and the rate of the time clocks, the clocks run at all different rates, all depend on where they are. We've known that for a long time, and they recently detected gravitational waves. So there is gravitational wave, meaning it's from general relativity. I don't think ether has resistance. Well, yeah, if it doesn't have, it couldn't have resistance, I don't think. Check out Barry Setterfield's zero-point energy theory. Explains why light is slowing. Yeah, he had. I mean, he's been around for a while. Barry Satterfield. He's been around for a while, and he's had like a lot of different theories, and he's renewed them. He's still. I think he's still modifying his ideas as far as the variable speed of light and everything. But I'm just showing that if you just take general relativity for face value, you can't have a constant speed of light. You're not sure you're going to have a constant speed of light here. If you're looking at cats and dogs, half of them is not going one speed and another half are going at another speed. The whole dog and the whole cat is all going at the same speed in the same space. But if you look at a galaxy, it's not like looking at a cat or a dog. If you had a cat or a dog the size of a galaxy, it would be skinny in the middle, and then you see this little thing spread out like this, and it'd be the big feet and tail waving, and they'd be moving a lot faster than the center part of the game. You're not looking at the same frames of reference. I mean, you're looking at a whole range of frames of references. You're not in the same frame of reference when you're looking at a galaxy. Anyway, I think that's how we generate electricity is by creating voids in either or what they call counter space. When the ether fills the void, you get electricity, electrical theory. It's complicated. Uh, there's all kinds of people that have videos and ideas about electromagnetism and electricity and the perturbations and all that stuff. But but yeah, I mean, there's probably more than one way to think about the same thing. It's just that general relativity is one way that's borne out to be have some relevance with observations. What we're looking at, that's the variable speed of light and the contraction of distance, which is gravitational waves, which is the first time they ever detected or measured a change in distance of the same distance, the variation of distance was with gravitational waves. This is the first time with the interferometers that they ever were able to do that. So they basically validated general relativity with when the neutron stars collided. They had two neutron stars, very heavy stars, so heavy that when they collided, it was like almost like a black hole colliding, except that when they collided, they weren't a black hole yet, so they could see the flash. So they figured out where it was in space, and they saw the flash from the two neutron stars colliding. Not only that, they detected and saw all the heavy elements that were being created, like gold, silver, platinum, all these heavy elements. They saw them being created in that flash of the two neutron stars when they collided, which is an amazing thing. It was the first time in all of history that they ever did that. E still equals mass by light, no matter the speed. Just a different EM wave firm would be my thought. Energy still equals mass by light. Well, yeah, energy, a mass is energy. It's just bound up energy, but it's still like existing at the speed of light. So it's or near the speed of light anyway. But it's bound up energy. It's like if you get a wire, if you get like a horseshoe loop or like a horseshoe or a U-bolt, you wrap a wire around the U-bolt, copper wire. You take a battery and put a charge on both ends, positive and negative, on the U-boat, and then place a metal on the U-boat like this, and then take the battery off. Of course, that's going to make a magnet, but you take the battery off, and it's still going to hold like a magnet, even with no electricity flowing in there. So it's like it's energy that's bound up together, and it'll hold it indefinitely. It'll hold the plate indefinitely without a battery on the U-boat. It's very, very interesting. So that's kind of like an atom, which has a charge in in the structure that's bound up. It's all kind of phenomenon. I mean, that's what we exist of, is this phenomenon of atoms, and that's what an atom is. It's bound up energy, and and you get different configurations, and you get different molecules and different elements, and or different elements to make different molecules. It's a really amazing thing. Pioneers of electrical theory that gave us basically our entire modern civilization deny the existence of electrons moving across wires. Tesla said it's absurd. Yeah, like I said, there's probably more than one way of looking at the same phenomena and describing it differently, but you're really describing the same thing, only in a different way. You can call it semantics sometimes. You can call it an ether, or you can call it space time, but you still have these observations that you have to verify whether or not it's actually true. Particles popping in and out of existence are becoming more frequent as time goes on. Refraction of light over distance takes longer paths, so it seems light is slowing. Okay, the particles popping out of existence. Uh, that's only in space time. It's only in space and time where you already have gravity, and so you already have a force there. So if things are like appear like they're going popping in and out of existence, because you already have the force there, and more frequent as time goes on. Refraction of light over distance takes longer path. Seems light is slowing. I don't. I don't know if light's slowing down. I used to I used to look at car headlights and think that, oh, the headlights are getting dimmer. Maybe lights are getting dimmer. But now we have LED. Now they're bright. But anyways, space time and electrons and photons are human conventions used for measurement. Yeah, it's semantic. It's a description. But it's good to try not to talk past each other when we're talking about the same thing, the same observations. We're just using different words or different descriptions of the same thing that we're both observing the same thing, right? Just electrons, photons, humans conditioned for measurement. Yeah, well, they had. I mean, I don't know. They spent years doing the studies, as far as electrons, photons, quarks, and up quarks and down quarks and charms and strange, and they keep on finding smaller and smaller amounts of energy, and they think it's such a great thing. Photon is packet of energy that science speaks for. They don't know what it is. Yeah, it's a packet of energy. uh, but then they keep on trying to find these smaller and smaller packets of energy, like I said, like the U-boat that's charged, that's holding a plate without without a battery. I mean, you charge once you charge it with a battery, it'll keep the charge in the U-boat, and it'll keep holding the plate, a steel plate, magnetized. It'll be keep holding the plate like as if it was a magnet because of the charge that's in the U-boat, and since it's continuous loop, that it's not cut. Well, once you cut it, and then it won't stick no more. You know, if you force the plate apart, then you got, in order to get it to stick, you got to charge it again for it to stick. Because once you break that circle, it's no longer going to stick. Okay. Nothing pops in and out of existence either. That's a misnomer. Virtual particles, which again is what I'm trying to make measurements. To make measurements. Yeah, those virtual particles are like potential things that don't actually come into existence. It's just, but it could if the conditions were different and other things involved, and so it's different. Not saying you're not useful. Not saying you're not useful. Not saying the conventions aren't useful. Not you. Like I said, the people that gave us our modern civilizations in the entire electric grid didn't believe in the existence of an electron. Yeah, but they knew. I mean, they knew there was this phenomenon called electricity. Okay, my theory: gravity is symptomatic weak force of electromagnetism. Example: the Earth's core, distant to the surface, has the pulling force weakness before letting go into space, such as pulling two magnets. Yeah. Now the study of gravity pulling apart magnets apart. The study of gravity is interesting because there's different. You have to be sure you know how to calculate gravity. I mean, the whole thing with the whole galaxy, you have to know how to calculate the gravity of the whole galaxy, plus the mass of the black hole and stuff. But when you're talking about the Earth and the Earth's core, it's like they say that if you go to the center of the Earth, then it's like the Lagrange point between galaxies that I was talking about. You have all the gravity, you have all the mass all around you, all pulling at you from all different directions. So if you're in the center of the Earth, there's not going to experience gravity. I mean, if you could, it's probably you can't exist in the center of the Earth because of temperature and everything. But if you could, and there was mass all around you, it's all pulling at you, meaning you're experiencing no acceleration there. Basically, even though the whole Earth is moving, but besides that, comparatively speaking, you're not experiencing acceleration. In other words, you're not going to fall either way. You're not going to fall up. You're not going to fall down. You're not going to fall either way because you're in the middle. So you're experiencing basically no acceleration in the center of the Earth. And which is a lot of stuff to think about, If you're in the middle of a black hole, how about that? But you can't be in the middle of a black hole. That's the problem. That's what I'm saying. It's theoretical. People think electrons are these little things that are not traveling down wires. There's no proof. There's a big discussion. They were arguing about whether the electrons were traveling outside of the wire or inside of the wire. There's a big argument about that on YouTube. It was supposed to be, I mean, to some extent, it is outside traveling outside the wire, but then you have to have a wire big enough for it to accommodate the the amperage and the voltage and amperage and stuff. If it traveled outside, because it would heat up, I guess. If it's too small, it would heat up. Anyways, but it, I mean, electricity is electrons moving. And the interesting thing is the with the ATP, because they say, we used to think it travels from positive to negative. They found out no, it's electrons. It's traveling from negative to positive. But in ATP synthase in the mitochondrial, um, in the mitochondria inside of the cells, they don't use electrons for to run the generator to spin the motors. The mitochondria uses protons, which are positive, so which do flow positive to negative, whereas electrons flow negative to positive. The mitochondria utilize positive protons that goes from positive to negative, and that's how it runs the motors. They call it an uneven gradient, but yeah, but that's what a battery is. A battery is an uneven gradient where electrons have to flow from, I guess, the negative side to the positive side, and but the protons in the mitochondria they flow from they're using positrons, or instead of electrons. They're using a positive voltage instead of a negative voltage. Okay, here we go. Okay, might be a dumb question. Here we go. Might be a dumb question, but why don't we get pulled into the sun? Why do we orbit? Because we have momentum, and we're the momentum that we have is keeping us in orbit around, which is another thing that I'm not too sure they understand. It might involve electromagnetism as well, but they don't like to admit it or talk about it, or they just deny it outright without slowly getting closer to the sun. Uh, Supposedly that we are going to get closer, to the sun, or we're, you know, unless there's something else pulling us off in other ways. Or I mean, there are other planets too. Maybe that's keeping us from going in. I don't know. But eventually, it's supposed to all go in the sun. So atom charge aligned creates force. Atom charge aligned creates force. Well, it's the positive. It's the uneven gradient in a battery. It's an uneven gradient where you have more electrons on one side, and the electrons want to go to the other side, and that's what creates the force. The more electrons you have trying to get to the other side, the more power you have. And that's ATP uses the same thing, only they have what they call a proton pump. The proton pump makes the uneven gradient, which is a battery. It runs a spinning electric motor, which manufactures ATP for us to exist. The wire acts as a long torus wave using the insulator as the wall. Okay, yeah, that could be true. I mean, because they say it runs on the outside. how do how do you manifest electrons from thin air? How come magnets moving across coil manifest electrons? Where are they coming from? Uh, well, it's the motion, it's the movement across the magnet that makes the electricity, and basically it's utilizing the motion to to get these electrons going, or to get them free to or to isolate them somehow. You could run a generator in a vacuum and it will still work. A generator in a vacuum? Yeah, but I don't think it, yeah, the generator in a vacuum will still work, but I don't think it's I don't think it's the atmosphere that's I mean if there's too much atmosphere, it would like short out possibly. But as long as it's dry, your generator is going to generate electricity because the atmosphere is not going to short out the generator. But a generator probably wouldn't work underwater. That's what I'm saying. Wave particle duality electricity is energy. Light wave travel on most easiest flow. Well, the light wave is supposed to already be there. I mean, as soon as the light leaves or the photon leaves, this photon is supposed to arrive. Except except in our case, we see it take time to arrive where we are, depending on how much gravity we exist in. You know, depending on how far we are from the black hole and other masses. Planets have 99.9 angular momentum, yet they say the sun has 99. The mass doesn't compute. Yeah. Well, I mean, the planets are trying to move in a straight line because with their momentum, they're trying to move in a straight line, and it's the gravity that keeps them in an orbit. But but we exist at a great distance from the sun. We on Earth and the planets are very, very, very far from the sun. We're not close to the sun. That's why we don't go into the sun right away because a lot of comets do go into the sun. Some comets go around the backside. Some of them don't make it. They just go right into the sun. But we're very, very far away, and so if we're getting close to the sun, it's not happening very fast. I think electricity is created by pressure mediation, perturbations. Magnets moving across the wire creates counter space or an imbalance that generates power. Yeah, somehow it's isolating the electrons or separating the electrons from whatever source that they're at. And it has something to do with the magnets. Check out Tycho's theory by Simon Shack. This will get you thinking binary systems with Mars and Sun in a dance around the Earth while the Earth is 26,000 year circular procession. 26,000 year circular procession. Oh, okay. Uh, I was I was pretty sure that the Earth goes around once a year. the sun. That's what makes our seasons spring, summer, and winter and fall. Sounds interesting. I love thinking about stuff. What's the difference between magnet before and after it's magnetized? Uh, that's a good question. The magnets do get weaker, and I think they get weaker with use. Um, but these neodymium magnets are like very strong. When a material is magnetized, its fields are aligned, creating the field that's externalized to the material. Yeah, they have. What happens is when it's molten, when they have in a molten state, they they align all the molecules or all the atoms. They align them one way, or they get aligned one way, and that's what what the magnet is that all the poles are all aligned the same direction, and then it solidifies, and they keep that position. That's what the magnet. Now, why you can magnetize metal is another thing, but of course, it's not nearly as strong. There's no quantitative difference. They run high voltage across it, and nothing quantitative changes. Think about the difference between 40-watt bulb and 50-watt laser. 40-watt laser. Yeah. Laser is coherent light and will burn a hole through you. They just run high voltage electricity across it, right? Theory works with Solarium, so as retrograde of Mars and planets can stay at a steady speed around the sun. If the theory was true, our parallax measurements will show the universe. Oh, shrinking by 43,000 times. Anyway, that's about it. I do have some ideas about the breaking up of the continents as well, and genetic haplogroups. The most recent thing I came across with the genetic haplogroups that I just remembered was that the Jewish populations have the Q haplogroup because back in the book of Esther, there were Medes that became Jews. And of course, the haplogroup of the Medes is what? It's a Q. And I was always wondering how did the Q, which is from the Medes, become part of the Jewish people? And the G Assyrian is obvious because they were expelled to Assyria, like who knows how many times. So there's a huge G haplogroup in the Jewish population. I mean, 15% or less, 10, 15%, depending on the study. But there's always this Q. And I was wondering, well, where did this Q come from? And then I remembered, yeah, back in the book of Esther, the Medes became Jews. And they're there. They exist in the Jewish population to this day. Anyway, okay. Okay, the fake neodymiums. Oh, they take neodymiums. They have a machine that runs high voltage across it, and depending on how they run it, it will create north-south pole. Yeah. Yeah, there's a manufacturing process for that. I think the point is that people make the mistake technology is actually for us actually understanding what these things are. We know how to manipulate them, but don't know what they are. Yeah, well, that's the thing. A lot of it is we know how to use it, but we don't know exactly what it is. Gravity. They still don't know what gravity is, even though they can predict a lot of things with gravity, but they still don't know exactly what it is. You know, with continents moving and crunching, piezoelectric lightning creates our heavy elements in the crust. Proton 21 laboratory proved it. That could be. That's interesting. I've heard that before, but it's an interesting thing. And the continents broke apart in the days of Peleg. They actually were all connected. They actually got to have a seal on them. South America, Africa, India, and Australia were all connected to Antarctica after the flood because they all have a seal on them, which is the glacial striations from when they were still connected to Antarctica after the global flood, because the sediments were deposited first. They were still connected to Antarctica until the days of Peleg when they broke apart. Then, when they broke apart, they still have glacial striations on the top of the bedrock today. So South America went north, and of course North America went north. Africa went north, and as they go north, they separate on a round Earth. They separate from each other as they go north, right? And Australia went that way, India went that way, Africa went that way, South America went that way. They all went north, and they all shoved all the animals in the Arctic up into the Arctic, where they instantly froze and or were buried by the tsunami, by the rising sea level of the all the continents being shoved up into the north. Of course, the sea level would rise. Tsunamis inundated and buried all the animals and ecosystems and trees and everything. Anyways, and there could have been a lot of piezoelectric activity at that time. 100 years after the global flood. Yeah, I read about the theory. It explains why we don't need to invoke radioactive decay. Walt Brown hydroplate theory. But but this one is during the flood. My idea or my evidence is from after the global flood. See, that's my favorite flood theory. Uniformitarian doesn't explain the age of decay. So so we have this seal on South America. It's still got the stamp, right, of the glaciers on South America. South Africa has the stamp from the glaciers. India has the stamp from the glaciers. Australia have the stamp from the glaciers from when they were all still connected to Antarctica, when they were covered with glaciers, at least the southern parts of them, southern part of Africa, South America, Australia, and India. They all have glacial striations from when they used to be connected to Antarctica. Then of course, they broke apart and they no longer have glaciers on them now, obviously, because they're not connected to Antarctica anymore. But in the process of breaking apart, they shoved the northern parts of the continents up into the Arctic, where that's what froze the mammoth and buried the mammoth with tsunamis and stuff like that. And they have huge evidence of tsunamis up in England or Nova Scotia and all them places, and they can't figure out where these tsunamis came from. But anyway, that's explained, and it explains how the animals got to where they were going, because the jaguar is the same thing as a leopard. It fits with Peleg the days, though. Yes, the days of Peleg, 100 years after the global flood, is when the earth was divided. The Bible says the earth was divided. Yeah, see, it's not like we could ever repeat this process on such a huge scale, but to see it makes more sense than millions of years of dirt created by perfect layers. Yeah, that makes no sense at all. That makes no sense. You have six mega sequences stacked on top of each other with no soil layers in between, no bioturbation, just layer upon layer upon layer, six mega sequences with no living life, you know, activity, no activity, just everything buried, just layer after layer after layer around the whole world. These six mega sequences are worldwide, but I don't know how they can claim that there's no flood. They find sea life everywhere on Earth. Well, whenever they find fossils, it's always mixed with marine life. I mean, you'd have some geologists come along and say, "Oh, not always," but most of the time, almost all the time, it's always marine life buried with land animals, which only makes sense in a global flood. But that's it. But I'm still trying to teach these scientists that the speed of light is not constant. Before the flood, there was 90 some percent land with small seas and springs. After the flood, the oceans divided, the high continental crust that slide on salt water until they met their crumpled up mountainous end. Yeah. There could have been more land area, but there were a lot of seas. I mean, there were the seas. The seas were full of life, full of marine life, and it's still a lot of life, but I don't think it's as much as what it used to be. But I don't think the seas were as deep either. I think the seas got deeper, especially when the continents broke apart. You can see they spread apart. The Mid-Atlantic Ridge where they spread apart, and it put pressure. It probably formed the Appalachians, the Brazilian highlands, the Appalachian Mountains, and the Rocky Mountains, and the Andes Mountains, and Peru and Chile and all that stuff from the pressure of when they were being spread out. And an interesting thing happened in the Pacific Ocean on the other side is the big what do you call it? It's where the ocean goes down deep. In the near the Philippines and everywhere. What do you call that? Anyways, the ocean, the pressure was so great that the sediment layer, I mean the plate, buckled under and formed the deep rift. What do you call it? Marianas Trench. That's what it is. Yeah. So explains oil mass. They just invoke floods everywhere on Earth, but that's yeah, but It's a global flood everywhere on Earth, is what the evidence shows. They say 98% of all species are extinct. Yeah, it's called genetic entropy. No, it's called the Earth was destroyed once already, and it's about ready to be destroyed again. And Revelation says the Earth is going to be worn out like a garment, which means the Mid Atlantic range. That's Mid Atlantic range is where that could have been. This could have been up out of the water, and that could have been like the lost city of Atlantis. But then it sank back down because to this day there's the Azores Islands that are still there, but the Azore Mountain rises up thousands of feet up in the air, and the Amazon rainforest at the most is like 400 feet 400 feet above sea level. The whole Amazon basin basically, and the Azores Mountains goes like thousands of feet up in the air. Uh, we killed all the big lizards and animals. I think Atlantis is just a pre-Diluvian world. I'm pretty sure it was post-Diluvian because they were writing about it. I mean, and they probably wouldn't have remembered the other one. Maybe it was, but they said it's past the Straits of Gibraltar. Atlantis was beyond Gibraltar. Is what they said it was. Anyway, I think that's about it for right now. It just bugs me so much that they're trying to say the speed of light is constant when and at the same time they're saying, oh, the clocks run at different rates, and there's gravitational dilation too. I mean, there's distance dilation too. So wait a minute. If you're measuring the speed of light using time and distance, and they're not constant, then how in the world is the speed of light constant everywhere throughout the universe for everybody? In it, it's like I don't know if they don't think of it or they just learn this stuff by rote and they just repeat the stuff and they don't think about what they're saying or something. I don't know what it is, but if it's true, if general relativity is true, which is general relativity is basically an observation right now. It's been observed because of the gravitational waves and changing rates of time, clocks running at different rates. So both special relativity and general relativity has been found to be true. Um, so if it's true, then the speed of light can't possibly and is not constant. Cannot possibly be constant. The speed of light is not constant, as they say, for all observers. They say the speed of light is constant for all observers in your particular frame of reference, but not everybody is in the same frame of reference. The galaxy is not in the same frame of reference as what we are. And if you look at a galaxy, it's not looking like a cat. It's not like looking at a cat or a dog, because the cat that you're looking at is not doesn't have different frames of reference, different measures of distance, or different rates of time from the middle to his tail. It's just one. measure of distance in one rate of time throughout the whole dog or cat that we're looking at. But if you look at a galaxy, you're looking at different rates of time throughout, different measures of distance throughout. And then they wonder why the spiral arms are going around faster than what they're supposed to go around. They wonder why the plasma jets are shooting out 7 times the speed of light. They're wondering why the Voyagers can't tell where he is. He's all mixed up, doesn't even know where he's at. The Voyager probe. Anyways, sometimes I don't think they think very much about what they say. Wait till the stars roll up like a scroll sheet, like a scroll. Stuff will hit the fan. Good night, God bless. Fique com Deus. Você também. Todo mundo fique com Deus. And have a nice weekend and a nice week next week. Yeah, God bless everybody. Take care. And stay with the truth. You will never be confused. If you stick with facts and truth, you'll never be confused.